Welcome back. I know you all missed me, so we're going to go ahead and finish up. We're going to start taking a look at question number 2 from the 2016 AP exam. And if you notice with this question right here, this is a particle motion question. And I know it's going to be a calculator question because they give me this ugly little part for the equation right there. So they give us this parametric equation. Parametric equation, and sometimes they'll say this is a vector as well, parametric as a vector. And then they give us dx dt right here. Now dx dt, they're telling us that this is a velocity problem right here. And the graph of y above. So this is a position graph for y. There's our position, and we're given the velocity. And they tell me the initial position of the particle is at 5, 1. So that tells me that this is going to be another fundamental theorem question, FTC problem right here. And look, lo and behold, there it is. Question A. Find the position at t equals 3. So to find the position, I need two things. I need x of 3, and I need y of 3. Now, one of these is super easy to get, and you guessed it, it's y of 3. Because I'm looking for the position of y, I just have to go to 3, and it looks to be about -1/2 right there. X of 3 is going to be a little bit different because they gave us the derivative, so we have to integrate. Remember, if they give you a rate, you must integrate. So I have to integrate dx dt. So let's see here. So to get x of 3, ready? We would integrate from, 0 to 3, x prime of t dt, dt, and that's going to equal x of 3 minus x of 0. There's our FTC step right here. We type this in our calculator. Now, I'm not going to type in my calculator, but you go ahead and do so. When you type in your calculator, you get something like 9.377 and 035 equals x of 3, which is what I want, minus x of 0. The initial x position is 5. So therefore, I can get x of 3 as 14.377. You only need to be accurate to 3 decimal places. So the position is going to be 14.377, comma, -1/2. And there is our answer for part A. Now, the only really hard part is just typing this in. So let's look at how many points this would be worth. Ready? You would get 1 point just for setting up the fundamental theorem. You get 1 point for just plugging in the -5 in the FTC, and you get 1 point for your answer. That's worth 3 points. Okay? Now, on the AP that we're going to take in 2020, this is going to be solvable by hand. It's not going to be nasty. It's not going to be something that ugly. Okay? All right. So there we have question part A. So let's go ahead and go to part B. Excuse me. Part B says find the slope of the line tangent to the path at xt equals 3. So, well, how do you find slope? Well, remember this is parametric, and slope is always, this is parametric or a vector. So we want y prime of 3 over x prime of 3. Remember, this is parametric. Okay? Slope is always change in x. Remember, slope is your change in x, dx, dt. Whoops, sorry, dy dt is terrible. It's embarrassing me. dy dx. Sorry. I messed up. Let me erase that, make it look a little pretty here. Sorry about that. Everybody makes mistakes, right? Don't judge me. There we go. Remember, slope is dy dx. It's a change in y over change in x. So we got our y prime over our x prime. So y prime of 3, this is just the slope of the graph at y equals 3. Slope of graph at y equals 3. So let's go back here to our graph. Here we are at 3. What's the slope? Up 1 over 2. So the slope looks to be about 1/2. X prime of 3? Well, x prime of 3, that's from our equation right here. So to get x prime of 3, it's going to be, what's that? 3 squared plus sine of, that's 3 times 9. Remember, that is t squared. And if you type all this in your calculator, you wind up with 9.95636 roughly. And simplifying that, you're going to get 0.05. And there's your answer. Now, it's not worth much because it's not a very long question right there. It's only worth 1 point, but not too bad to do. All right, now part C, this is our speed. Remember, speed is the magnitude of velocity. So to get part C, remember, we're just going to take it's just the square root of x prime of t squared plus y prime of t squared. So we're going to get this. So it's the square root of, what's that become? X prime of t at 3. We already know, oh, look, that's our 9.956 squared plus y prime of 3, which we said was 1/2 squared, right, at t equals 3. I'm just plugging in everything we did from part B. This is from B. And if you type all that in your calculator, you get 9.969 or 9.968. Either one's acceptable there. You can leave this. You can leave this if you want to. Okay, AP will be okay with that this year. Just leave it alone. Okay, now this is worth 2 points. So let's take a look where those points come from. You get 1 point for your setup, 1 point for your answer. And now if you ask me, Mr. Warnoff, you can leave it like this. They still give us a point. You still get both points for it. Okay, all right, very good. Hope you guys are doing good so far. This is a pretty easy question. All right, for part D right now, we're looking for the total distance. Well, total distance remember, total distance is that integral from A to B, right, of our magnitude, of our velocity equation. So, from 0 to 2, our magnitude, ready? We're going to get x prime of t squared plus y prime of t squared dt. So let's see here. Now, so for integrating 0 to 2, x prime of t, well, they told us that's our t squared plus sine 3t squared plus y prime of 2. This is going to be a constant for us. And if we go back over here at 2, so from 0 to 1, the slope here is -2. So when we go back over here, the slope on 0 to 1 was -2. So this becomes a -2 squared dt. Ugh, nasty. Now, you're going to get 1 point. Whoops, this is not working very well for me today. You will get 1 point for just the setup. You get 1 point for getting the integral. And now, let's go and get up the answer. If you type it in your calculator, you can get something like 4.350. Now, on the AP this year, since it's really going to be a non-calculator one, they're just going to have it just set it up. They're not going to have to get the answer. You're not be able to solve it necessarily. But that'd be worth 3 points right there. All right, so anyway, so we just finished up question number 2 right now. I'm about to go ahead and go do question number 3, so hold on there. Again, if you need to pause it, please feel free to do so. If you need to stop it, go back, take a look at it, okay? Hope you guys enjoyed this question. I'll see you for example number 3.